Hello, welcome to my channel. We will be doing question 21. This is the last question of this chapter, chapter 11. It's pretty interesting. Okay, you see, it is given that the second, eighth, and 44th term of an arithmetic progression. Okay, so we're talking about an arithmetic progression. So its nth term, we know, which is the color, like the colorful thing. Okay, red color. Okay, so an is equal to a plus n minus 1 into d, right? We know this thing. Okay, so what about the second term? Second term is going to be a plus 2 minus 1 into d. Okay, and eighth term, a8 is going to be a plus 7d. And similarly, a 44th, it is a plus 43d, right? Okay. It's also known that the first term is 1. So it will become 1 plus d, and this will be 1 plus 7d, and this will be 1 plus 43d. Okay. Now these three are known as the first three terms of a geometric progression. Okay, this is interesting. So these these three terms are the first three term of a geometric progression. Okay, so if it's a geometric progression, then the common ratio would be the same. So it means 1 plus 7d divided by 1 plus d. It would be same as 1 plus 43d over 1 plus 7d. Make sense or no? In common, if you have a geometric progression, then the second and first term, the ratio between second and first is the same as third and the second. So we are exploiting this fact. Okay, so I will solve this equation and find the value of d. If I do the cross multiplication, it's going to be 1 plus 7d and its square is equal to 1 plus 43d into 1 plus d. Okay, so let's simplify this. If I open this square, it is 1 plus 14d plus 49d squared. Am I right? And when I multiply these two terms, it's going to be 1 and a plus 43 plus 44d, okay, and plus 43d squared. Okay, I hope I'm right. Okay, so 1 cancels with 1. Okay, 49d squared minus 43d squared is going to be 6d squared. Make sense? Okay, and minus 44 and plus 14 is going to be minus 30d, and everything is equal to 0. Okay, I hope you understand how I go from here to here. Okay, so if I divide everything by 6, it's going to be d squared minus 5d. So d, if I take common, it is d minus 5 equals 0. So this is giving d equal 0 or d equal 5. So this I will not take because it will not give you some another answer. I'll take this one. The common difference is 5. Okay. Show that the common difference of the arithmetic progression is 5. So we are done. Okay. Now the second part is that second part of the problem. Let's find the fifth term of the geometric progression. Okay, interesting. Now, as far as geometric progression is concerned, the first term of the geometric sequence, okay, let me write it here. It was 1 plus d. The next term was 1 plus 7d. And the next term is 1 plus 43d. Right? Okay. So, and if I take d equal to 5, so this is going to be 6. Okay, and this goes on. Okay. And d is equal to 5. So it is 5 times 35 is 136. And 47 times, let me do the calculation. It is 1 plus 43 times 6. No, sorry, 5. Okay. So it came out to be 216 and so on. And of course, let me make sure that 216 divided by 36, it is 6 years. It's a geometric progression. Okay, so we need to find out the sum of, sorry, yeah, find the sum of the first 20 term of the arithmetic sequence, sorry. Okay, so we start to work with arithmetic sequence. Okay, so it is easy. For arithmetic sequence, the sum of n term is n by 2, 2a plus n minus 1 into d. Right, you know this thing. Okay, so if I want to find the sum of 20 terms, is going to be 20 by 2 is 10. A is 1. First term is 1, remember? First of all, the arithmetic sequence is 1. So this is 2 plus 20 minus 1 is 19 times 5. So this is going to be 95 plus 297 and it's going to be 970. Okay. Now let's do part B1. Okay. Find the fifth term of the geometric progression. Okay, now I need this information. I wrote it there by mistake. Okay, so I know that my geometric progression is 6, 36, 216, and so on, right? So I need to find out the fifth term of the geometric progression. So a fifth is equal to a r power 5 minus 1, 4, right? Okay, so what's the first term? First term is 6. Common ratio is also 6 and 6 power 4. Okay, so this all becomes 6 power 5 and 6 power 5 I calculated as, let's do this, 6 power 5 is 7776. 7776. Let me count it again. Okay, now the second part of part B, this is easy. Explain whether or not the sum to infinity of this geometric progression exists. You see, if you look at this geometric progression, this one, it is increasing. So if I try to add infinite, it will not find it, right? It keeps increasing to infinity. And you can see that common ratio needs to be less than 1 if you want to find the sum to infinity. But in this particular case, common ratio is 6. It's more than 1. So that's why we cannot find the sum to infinity. Okay. I hope you understand. You can explain it in words as well. Thank you very much for watching. See you in the next video.